word of all. Okay, here we go. Shh. Ask your science teacher that. Ask him what the mass of the universe is. Okay. Scientific notation. Let's talk about this. You've worked with this before. You might be somewhat familiar with it, which is good. A number written in the form C times 10 to the n. Oh, shh. You don't need your calculators quite yet. A number written in the form C times 10 to the n, where C is a number between 1 and 10. So basically, this number can't be bigger or less than 1. It has to be less than 10. It's going to be a decimal usually, okay? And n is an integer. Is 1/2 an integer? No. No. Is -2 an integer? Yeah. Yes. Okay. 21 is an integer. A decimal is not an integer. Okay. So it says here, if the original number is 10 or greater, the decimal point has to move to the left and the n will be positive. This is when you're taking a number and putting it into scientific notation. If a number is smaller than 1, the decimal point has to move to the right, so the n will be negative. So if I want to write 100 in scientific notation, in order for it to fit the criteria for C, I have to write it as 1.0 times 10, and then I got to figure out what n is. If I have this, how many times do I move the decimal place to get it to 100? 2 places to the which way? Right, so I've got to multiply it by 10 to the 2. Okay? All right, I want you to go to your calculators. On your calculator, I want you to put in, let's see if I can get it so you can see. Put in 4.2 times, you watching? 10 to the -2. So yours might look a little different than mine. You might have a little arrow key. I don't know, what does it look like mine, Alnos? Does it look like this? Okay. What do you think it's going to be before you push enter? Before you push enter, think about it. What's it going to be?
-420. 420.
No, 0.042.
Let's see. 0.042.
Oh.
Negative exponent makes it move to the left. The little arrow key right here. The little arrow key under the clear button. Okay? All right, let's do 4.2 times 10 to the 3. Don't push enter. What do you think it's going to be?
4,000.
Yeah. You need me to zoom in? 4.2 times 10 to the 3 will be 4,200. Okay? All right, let's do another one. You ready? 3.754 times 10 to the -3. Now, don't push enter. Think about it. Which way is it going to move? To the left. How many places?
3.
How many zeros are we going to have?
2.
Very good. See that? Okay, I want you to do one more. You ready?
Yeah.
Because these calculators sometimes do something funky. How about 10 to the -4? Push enter. We know it should be 0.0003754. Look what it does.
Has an E.
Yes, it doesn't actually give you the number. It gives you scientific notation. This is scientific notation. It's saying, okay, that means you move the decimal 4 places to the left. So when you see that on these calculators, that means scientific notation. Okay? I just wanted you to kind of visualize the left and right movement. So that's really all. You might need these later, so you can hold on to them. But, all right, let's start writing some of these in scientific notation. So, I need to write this huge number in scientific notation. The first thing I'm going to do is put the decimal 1 digit in. So my decimal has to go there. Can you see it? Decimal has to go 1 digit in right here. So I'm going to have 2.675. You write all the numbers that are not 0. Well, sort of. I'll show you what I mean in a second. Now, I need this number. I need to multiply it by 10, and I got to figure out the exponent that will take this number back to this number. So I got to move it to the right. How many places to get back to my starting number? Let's see, it's 1, 2, 3, 4, 5, 6, 7, 8. So 2.675 times 10 to the 8 will get me back to that number. Got it? Every time you multiply by 10, what does it do? It moves the decimal. Every time you multiply by 10 in positive direction, in the negative direction, it moves it over to the left one. All right, where would we put the decimal here if we have to write this in scientific notation? After the 4. So I'm going to write 4.86 times 10. And then I'm going to figure out how many places I got to move it to get back to my starting number. So 1, 2, 3, 4 places to the left, because I'm getting smaller, so it's going to be -4. Okay? I'm going to go from big to smaller, so I got to move it to the left. All right, so now we got to take this and write it in standard form. We're going to move it. It's going to be moving the decimal how many places? 5 times which way? To the right, because we're going to make it bigger. We're multiplying by 10 every time. So it's going to be 7. Wait a minute, hold on. 1, 2, 3, 4. Oh, I got an extra spot. What do I fill it with? A 0. Now what I do after I write all the numbers down, I go back in and put my commas. There's 1 comma in there. Every 3 digits there's a comma, starting from the end. Okay, so it's easier to read that number, 702,340. Yeah?
Yeah.
All right, 3.096 times 10 to the -6. So which way do I have to move it? How many places? Okay, let's just stop and think. If I have to move it 6 places to the left, how many zeros are going to be before that 3? 5, correct. 1, 2, 3, 4, 5. 3, 0, 9, 6, and put the decimal there. And that's it. Yes? Okay. Not too bad so far? You know the backside always gets better, right? You had to pick up both sheets. Because I forgot to make copies, so I had to print them. All right, I'm going to show you 2 ways to do this. So, take a look at this. Is all multiply, isn't it? Basically it is. Now you can do it 2 ways. You can convert this to its actual number, which would be what? Can anybody tell me? This one right here? What would it be? 5712, because I move it 3 places to the right. 5700, sorry. And then I could convert this to its actual number, which would be 2, 6, and 3 zeros. And then you can multiply them together, and you get this massive number. Are you ready? Okay, so then I have to write that in scientific notation. So I'm going to put the decimal right here and write 1.482. How many times would I have to multiply by 10 to get it to my original spot? 1, 2, 3, 4, 5, 6, 7, 8. So it's time 10 to the 8. Okay, now, the other way to do it, last hour I didn't really like it, but I think you should see it both ways. This is one way. I'm just going to show you another way right now. It's not continuing this. So here's the second way. This is all multiply, isn't it?
Yeah.
So I can do multiplying in any order. Correct? I can do it in any order. So I'm going to multiply these 2 together. Oh wait, this is a 4. I'm sorry. 10 to the 7. You see that? You see what I did? Okay. We're not quite done because it's not in scientific notation, is it? So first, before I do that, let's think about what this number is. This number says I have to move it to the right 7 spots, correct, to get the original number, right? So in order to write this in scientific notation, I have to move it 1 more spot over, so I'm actually going to have to move it how many times to the right? 8. So that's the other way to do it. Either way, I don't care. Okay? All right. 2.4 times 10 to the negative 4 squared. Wait a minute, what did we just learn? What do we do when we have a power to a power? We distribute the 2, so we have 2.4 squared times 10 to the negative 8. And then you just do 2.4 squared, which would be 5.76. Oh, beautiful. It's already in the right form. So I can just do it like this, and there's my answer. Because how do I know it's in the right form? Because there's 1 decimal here. Okay, ladies, I'm going to ask somebody to get off the couch. Please. Somebody get up and move. Okay. This one has a lot of words. It's not really that bad, though, I promise. When a picture is taken with a digital camera, the resulting image is made up of square pixels, which are really, really, really tiny. You've heard of the word pixel before?
Yeah.
Yeah. Different cameras have more pixels, give you better pictures. The smallest unit that can be displayed on a monitor. For one image, the side length of a pixel is 4 by 10 to the negative 3. So those really, really tiny squares, they're saying that's how long its side length is, which is really a small number. It's like this. Correct? Of an inch. A print of the image measures 1 by 10 to the 3 and 1.5 by 10 to the 3. Pixels. That's how many pixels are on this side, and that's how many pixels are on this side. Pixels, pixels. Okay? What are the dimensions of the print in inches? Oh, well, each pixel is this big. Each pixel. And there's this many pixels here. So I got to multiply how many there are by how big 1 is. So I'm going to take this and multiply it by how big 1 pixel is. Oh, this turns out way too pretty. Are you ready? Look at it's multiply, so it's any order. So I'm going to do 1 times 4 times 10 to the 3 times 10 to the negative 3. Oh, what's going to happen here? What's 1 times 4? 4. What's 10 to the 3 times 10 to the negative 3? Times 10 to the 0, which is equal to what? So this side is just 4 inches. All that work for them to tell you it's a 4 by whatever. We'll see what this side is. All right, so there's this many pixels here, and each pixel is 4 by 10 to the negative 3 inches long. So you do the same thing. 1.5 times 4 is 6 times 10 to the 3 times 10 to the negative 3 is what? Oh, 10 to the 0 again. So this side is 6 inches. All that work to just find out it's a 4 by 6. Dimensions, you want to finish the problem properly, are 4 by 6 inches. Okay?